Assalamualaikum warahmatullahi wabarakatuh to Medan Zalina. My name is Muhammad Fahmi bin Mohamed Noor. My partner for this lab video is Ahmad Akmal bin Azman. So in this lab, we will configure BGP with default routing. Here is the topology. We have R1 as ISP1, R2 as ITA, and R3 as ISP2. Next, the objective of this lab is to configure BGP to exchange routing information with two IPs. The background of this lab is the International Travel Agency (ITA) relies extensively on the internet for sales. For this reason, the ITA has decided to create a multi-horn ISP connectivity solution and contracted with two ISP for internet connectivity with fault tolerance, because the ITA is connecting to two different service providers. Then in this lab, I must configure BGP which runs between the ITA boundary router and the two ISP routers. Next, to start the configuration, I will apply the configuration to each router along with the appropriate hostname, such as for R1, the hostname is ISP1, the R2, the hostname is ITA, and last one, router 3, its hostname is ISP2. So in the step 1, I will configure interface addresses. So I will create the loopback interfaces and apply IPv4 addresses to this and the serial interfaces on ISP1, ISP2, and ITA. The ISP loopback simulate real networks that can reach through the ISP. The two loopback for the ITA router simulate the connection between the ITA boundary router and their core routers, and I will set a clock rate on the DCE serial interfaces. So here is the command on the ISP1. So I configured the interface for loopback 0. Then I use command description ISP1 internet network. Then I insert the IP address. Next, I configure the interface serial 30. As I use in GNS3, I use interface serial 30. Then I insert the description ISP1 to ITA. Then the IP address, and the last one to, and I also set the clock rate, and most importantly, I put command no shutdown for interface S30. So here is the ISP1 terminal. Okay, here is the command that I already configure. So as you can see here. Okay, next, for the ITA router, I configure interface loopback 0. The description is core router network link 1. Then insert the IP address. Next, configure interface loopback 1. The description is description core router network link 2. Then insert the IP address. Next, configure interface S30, and the description is description ITA to ISP1. Then insert the IP address, and most importantly, configure the no shutdown command. Next, the last interface in ITA is interface serial 31. As I use in GNS3, I use serial 31. So the description is ITA to ISP2, and set the IP address. So here I also set up the clock rate, and last command, the most important for this interface is no shutdown. So this is the command that I already configure in ITA. Okay, you can see here. Okay, next we go to ISP2. So here in ISP2 I will configure interface loopback 0. The description is ISP2 internet network. Set the IP address, and then configure interface serial 31. The description is ISP2 to ITA. Then insert the IP address, and the most important is the command, the no shutdown command. Then then the lab asked me to ping the connectivity from the ISP1 to ITA, ITA to ISP1, ITA to ISP2, and ISP2 to ITA. So in the ISP1, the ping here, I ping to ITA, successful. Next, ITA, I ping to ISP2 here, successful. And then I ping to ISP1 also, successful. Next, ISP2, this is ping to ITA, also successful. But ISP1 cannot reach ISP2. Then the next step is I will configure BGP on the ISP routers. So first I go to ISP1. So here is on the ISP1 and ISP2 routers, I configure BGP to pair with the ITA boundary router and advertise the ISP loopback networks. So this is so I will just show my in my ISP1 terminal here. Okay, here is the configuration of BGP on ISP router for ISP1. Okay, done. So we go to check on ISP2. Still here. Okay, next, step 3, I will configure BGP on the ITA boundary router. So I configure the ITA router to run BGP with both internet provider. So we go to ITA router, then okay, here is the configuration. Okay, here I configure the BGP on the ITA boundary router. Next, to verify the before that, I will see BGP enable pairing message on the console similar to the following. So here is the BGP enable pairing message. Okay, I get same as at the lab sheet. So to then next, to verify the configuration, I use show IP route command. So here is my show IP route command. So as highlight at this lab sheet for BGP here, same output as the lab sheet. Okay, so I already verify the configuration of the BGP on ISP router and ITA router. Next, I run the TCLSH command. Then I ping all these IP address, and all the IP address is successful. Here is the result of the ping for all of this IP address. Okay, next next step is step 4, verify BGP on routers. So to verify the BGP, I use show IP BGP command. So here is the command, show IP BGP. Then the result is same as the lab sheet. So it is verified that BGP is already configured in the routers. Okay, next we go to the question here. What is the local router ID? So from the configuration, the local router ID is IP address 192.168.1.1. That's the answer. Next question is which table version is display? So the answer is the table version display is 5. If there were any misconfiguration that were later corrected, value may be higher. Okay, next, to verify the operation of ISP1, I use show IP BGP command on ISP1. So here is the configuration of this command. Okay, as shown in the lab sheet and what I have configured, it show the same result, same output. So next we go to the another question. Which table version is displayed, and is it the same as the BGP table version for ITA? So the answer is the table version display is 5, which is the same as display for ITA. So you can see here 1, 2, 3, 4, 5. So same. 1, 2, 3, 4, 5. Okay. Then next question, from ISP1, what is the path to network 172.116.1.0/24? Okay, the answer is the path is through AS200 at ITA and AS300 at ISP2. Okay. Okay, next is on the ISP1 router, I issue the shutdown command on loopback 0. Then on ITA, I issue the show IP BGP command again. So I show that at the ISP1. So here is the command that I already shut down the loopback 0. Next I go to ITA. Then I will run the show IP BGP. Okay, here is the this is the output. So you can see that this is also the loopback 0 is already been shut down. So here from before we can see we have 4 IP address here. Then now we have only 3 row only. From 4 we have 3 because we have shut down the loopback 0. Next, we go to another question. Which table version is displayed and why? The table version is displayed is an increment of the last one, which is 6 in the example. The shutdown command caused a routing table update, so the version should be one higher than the last. Okay, that's the answer. Next question. What happened to the route for network 10.1.1.0/24? So the answer is, it is no longer in the BGP table because the interface loopback 0 on ISP1 is already shut down. Okay, to continue this lab presentation, I will pass it to Akmal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal bin Azman, and I am going to continue to answer question C and demonstrate all the other steps until step 7. Okay, for C, issue the shutdown command on loopback 0. Then show the IP BGP command on ITA. Okay, this is the output for IP BGP before I shut down the interface loopback 0 on ISP1. Okay. Okay, now show IP BGP on router ITA. It is not show here because I've already shut down the loopback interface. Okay, which table version is displayed and why? Okay, the table version displayed is 6. It is because whenever I use the shutdown command, then it will update it in the routing table by increasing the version by 1. Okay, what happened to the route for network 10.1.1.0, which is the router 1 loopback? It is no longer in the BGP table because the interface is already down. Okay, next, issue the no shutdown command. Then show IP BGP neighbors. Based on the output of this command, what is the BGP state between this router and ISP2? ISP2 state is established and the connection has been up to 8 minutes and 33 seconds. Okay, that's all for step 4. Next, step 5, to configure route filters. Okay, check the ISP2 routing table. Show IP route. Okay, ISP2 should have a route that belongs to ISP1. Okay, then trace route to interface loopback ISP1. Okay, not successful because you can see here ISP1 does not have a route to the source IPv4 address of the trace route, and BGP networks doesn't advertise the links between providers and BGP. But if we trace route using the loopback interface, then only can be successful because it's showing that the ITA, the router ITA, is a transit for this network, not the BGP networks. Next, configure the access list for ITA. apply this access list as a route filter using the distribute list. This is for ISP1 and this is for ISP2. Then check the routing table for ISP2 again. The route to 10.1.1.0, which is ISP1, should still be in the table. Yes, it is still there. Then to ITA back, apply this command, clear IP BGP asterisk. Wait for several seconds. Okay. Recheck the ISP2 routing table. Okay, the SP1 network should no longer be in the routing table for ISP2. Okay, then after several seconds, after we reset the all BGP adjacencies, as you can see here, the network to look back ISP1 does not shown in routing table ISP2, and we have these two routes to interface loopback ITA. Show IP route for ISP1. So this is the route to router to loopback. So that's all for step 5. Next, for step 6 is to configure primary and backup routes using floating static routes. Okay, show IP route for ITA router. Okay, no gateway of last resort defined, means that there is no static route configured or default static. Next, to configure static routes to reflect the policy that ISP1 is the primary and ISP2 as a backup. To interface to ISP1. Next, to interface to ISP2. This one is higher because we want to make this is the primary one. Okay, show IP route. Gateway of the result is 10.0.0.1 to network 0.0.0.0. That means that we have configured static routes for router ITA. Okay, test this default route by creating an unadvertised loopback. Okay, show IP route for ITA. Okay, they configured the newly added IP address in interface loopback 100 for router 1 is not shown in the routing table router ITA. And if we try to ping but if we ping the newly added IP address, it is successful because we have configured the static routes to router 1. So that's all for step 6. For the last step, step 7 is to using BGP to propagate the default route. So instead of we use the static route, we use BGP. So ITA. Then configure ISP router, ISP1 router to send a default route to its neighbor, the ITA router. Okay, next show IP route. Next to verify that the default route was received by ATA using BGP. Okay, we need to wait for several seconds before this line shown in the IP routing table, for router ITA. Okay, after several seconds, the routes, the default routes using BGP has been received by router ITA. So that's all from me, Ahmad Akmal, and Fahmi for these lab activities, lab 7 BGP. Thank you.